Welcome, this is Mrs. Nearing, and I'm going to talk through a quick review of atomic structure from general chemistry. On this page, you can see a visual of the various models of the atom and how that our understanding of the atom has changed over time. And our most current understanding of the atom has to do with this, you may have heard this electron cloud idea. We will get into more with electrons in a little bit, so that we'll get that later on in this unit. Right now we're going to focus more on what the subatomic particles are, and we're going to focus more on what's going on inside the nucleus, thinking about mass and isotopes. So a general overview of the subatomic particles is there's protons and neutrons in the nucleus. Protons are positive, neutrons are neutral. Their masses are equal to each other. And then there's electrons surrounding the nucleus. So we're just going to be vague here and say they're around the nucleus for now. We'll get into more detail with that later. Their relative mass is so tiny, it's essentially zero. It's insignificant compared to the mass of the protons and neutrons. And then electrons have a negative charge. When you look at the periodic table, some things you will see, this number here at the top is the atomic number that tells you how many protons are in the nucleus of an atom of that type of element. That is the thing that distinguishes elements from each other, is the atomic number. So the number of protons is what makes carbon carbon and what makes zinc zinc. So each element has a unique atomic number. Atoms are neutral, so the positive charge is equal to the negative charge. So that means the number of protons is equal to the number of electrons in a neutral atom. So zinc has 30 protons. It will also have 30 electrons in it. Looking at neutrons, there's no direct information on here about the number of neutrons, but what we do know on the periodic table is the average atomic mass. So boron is 10.811. The average atomic mass is a weighted average considering all the atoms of this type that exist in the world. So boron, for example, has two isotopes, so two versions of boron that have different masses. So some of the boron atoms out there in the world weigh 10, some weigh 11. For boron, it turns out that 80% of them weigh 11 and 20% of them weigh 10. And so the average atomic mass is somewhere between 10 and 11. It's a little bit closer to 11 because more of the atoms weigh 11. So that's why this average atomic mass is a decimal. It's because it's an average, and not all atoms of an element weigh exactly the same. Okay. There's some info in here about mass number, which I think I talk about on the next page. Okay, so there's something called the mass number, which is not on the periodic table, but it's these numbers right here, boron 10, boron 11. The mass number is the number of protons in a particular atom plus the number of neutrons. So that's going to be specific for a certain isotope, for a certain type of atom. And you can rearrange this to find the number of neutrons. So like boron 10, since it's boron, we know it's got 5 protons. Its mass number is 10. That's what the 10 means. So the number of neutrons is the mass number of protons. So boron 10 has 5 neutrons in it. Boron 11, turns out, has 6 neutrons in it. So we can see here, isotopes have the same number of protons but different numbers of neutrons. That's what gives them different masses. Some review of some things we want to remember from regular chemistry about the periodic table and shells and things like that. Some things you may have learned is that the column number on the periodic table, if you look at these blue numbers here, 1, 2, 3, 4, 5, 6, 7, 8, the column number corresponds to how many electrons are in the outermost shell, valence electrons. So we'll come back to electrons in a little bit, but I just want to remind you of what you learned in regular chem. And then if you look at the row number, that tells you how many electron shells there are. So if I were to look at iodine over here, it's in row 5. That means it has 5 electron shells, and there are 7 electrons in that outermost shell. So summary, protons, neutrons in the nucleus. Electrons are on these things called shells or rings or clouds surrounding the nucleus. Number of protons in the nucleus is equal to the atomic number on the periodic table. Neutrons plus protons gives you the mass number. Number of shells equals the row number on the periodic table. And the number of valence electrons equals the column number on the periodic table. So these are some of the things we might remember from regular chemistry. So if we were to stop and practice, if we were to look at a periodic table for calcium, let me just draw what I see there. On my periodic table, this is what calcium's box looks like. So some information that tells me is that there are 20 protons in an atom of calcium. That means there will also be 20 electrons. And if I guess on the number of neutrons, I am also going to guess that there will be 20, because notice that the average mass is close to 40. So that tells me that most calcium atoms have a mass number of 40. That means the number of protons and the number of neutrons are going to add up to 40. All right, if I look at aluminum, aluminum looks like this. I got 13 aluminum, 26.98. So aluminum, that number on the top tells me there's 13 protons. Since this is neutral aluminum, I know it's neutral because there's no charge given. So if I don't see a charge up here in the right corner, that means it's neutral. So therefore, the number of protons must equal the number of electrons. So your number of positives need to equal the number of negatives. And then notice here the average mass is close to 27. So remember, that's the mass number. So that means the number of protons and the number of neutrons in most atoms of aluminum, that'll add up to 27. So what that means, if I were to pick up a random atom of aluminum, it would likely have 14 neutrons in it, because 14 plus 13 adds up to 27. So that's our kind of process there with this. All right, so isotopes, we'll kind of get into more details here. Some things we have already kind of alluded to earlier. So an isotope is isotopes are versions of, let me write this out, isotopes where you have the same element, which means the same number of protons, because that's what defines the element, but a different number of neutrons that will give them a different mass. So for example, the way you name an isotope is by its mass number. So for example, we might call it carbon 14. This is an isotope with carbon that has a mass of 14. You could also write it this way, where the mass number goes on the top and the atomic number goes on the bottom. So if you see a number on the upper left, then that is the mass number. So if you see this, like 24 mg or 25 mg, that's magnesium with a mass of 24 or a mass of 25. So here's a page kind of summarizing some examples. So these are the 3 common isotopes of carbon. The average atomic mass of carbon is 12.01. That tells us, since the average is super close to 12, that means carbon 12 is the most common version of carbon, and there's only a few of them that are carbon 12 or carbon 13 or carbon 14. So most carbons have a mass of 12. This is the most common. And here's a formula, an example of how you would calculate the average atomic mass based on data with like percent abundance. So if we go back to the example of boron that we mentioned earlier, 20% of boron atoms have a mass of 10, 80% have a mass of 11. So the way that you find the average mass, you take 20% of 10, and you take 80% of 11, and you add those up, and you get 10.8. So we want to check for reasonableness. The answer should be somewhere between 10 and 11, but it should be closer to 11 because there's more 11s than 10s. So, cool. Mass spectrometry is another kind of view of mass spec that we've talked about on like page 4. And you can think of this, one of these mass spectra as just being a different way of presenting data. So you might just kind of read this graph and say, oh, it looks to me like 75.78% of this sample has a mass of 35, 24.22% has a mass of 37. I could find the average following that pattern we showed on the previous slide. So I could take 75% of 35 and add it to 24. Whoops, I gotta convert it to a decimal. 24% of 37, and you add those two up, and you should end up getting something around like 35.45 if you plug that in your calculator. And this is the mass spectrum of chlorine. I know it's chlorine because if I look on the periodic table, chlorine looks like this, 35.45, 17. So its mass is close to 35. I also want to mention ions. We'll get into ions more when we get into bonding, but vocab just to review, an atom with a charge is known as an ion. Atoms can gain or lose electrons to form an ion. So in an ion, the number of electrons is not equal to the number of protons. If an atom gains electrons, you end up with a negative ion. If an atom loses electrons, you end up with a positive ion. So like if an atom of sulfur gains 2 electrons, it will form the S2- ion. So now it's got more negatives than it does positives. So overall, it's got a negative charge. All right. So if we do a quick practice, how many protons and electrons are in a neutral atom of phosphorus? So if you look at phosphorus, it's got 15 protons, so it also have 15 electrons. Phosphorus with a -3 charge, well, it's still phosphorus, so it's still got 15 protons, but it's got a negative charge. That means it's got some extra electrons floating around. So it's got 15 positives, 18 negatives. That adds up to -3 overall. Okay, calcium neutral has 20 protons and 20 electrons. Calcium with a +2 charge still has 20 protons because it's still calcium, but now it lost some electrons, so it's only got 18 electrons. All right, so that's a quick review of atoms, atomic structure, and isotopes and ions. So hope that was helpful.